This is a Slant Nose Turbo that was having trouble with the headlight lift motors on either side. These headlight lift motors for this car are actually RX7, Mazda RX7 lift motors, and they are operating independently. The factory arrangement has a bar that goes between the two and operates off a single motor that's under the hood. In these conversion cars, they had to set up an operation that would allow the headlights to lift simultaneously, but without a physical hard connection between the two, in terms of mechanical hard connection between the two. So the problem was that this was not lifting the motors properly, and one would not come up, the other one would not come up properly. So I'm going to do a low-tech approach to take you back through some photos of diagnostics and explanation. Each of the two front headlight buckets has a set of wiring inside, and the part that we're going to concern ourselves with mostly is down here, this yellow, white, and red wire that come in by way of in this particular car, it's like a twisted black tape around them, and the other side has a similar setup with those coming out. The other wires that are in here, these are ground and parking and blinker that go out and down and underneath the car to the actual light fixtures. And then this cable brings in the blinker and the parking, as well as a ground. And it also brings in the low beam and the high beam for the headlamps. Now, most of the discussion is really going to revolve around these three, because these are controlling the lift up and down of the motor. The lamps simply turn the bulbs on and off, and parking and blinker operate independently. So while there are a lot of wires here, these are the ones we're going to concern ourselves with. The lift motor is here. It has the motor body. It has a worm gear and in here. So the worm is down this side, and then a gear down here. There are three wires, and we're going to pay a lot of attention to these, the three wires that go into this disc that's on the inside of the worm gear. Note that is a green, a red, and a red with a yellow. This white wire is what actually powers the motor, that of course has to be connected back to ground. So that's what these are, is ground. And we'll get to how these connect up in just a minute. But the main thought is that this red with a yellow, and then this red with a white are going to be what are going to control what happens inside the bucket. Inside the bucket, in addition to this device, is one additional relay. We'll get to that in a few minutes. I'll flip through some of these, and you'll see that the motor has a little bundle that comes out, and these are just the same wires connected back to the motor. The white with the red, the red, and the red with the yellow. They're just on a length of cable that is part of that assembly. When I opened up the bucket, these were some of the connections that I found, and these really are not related to the lift. These are the parking and blinker, and they have these plastic Porsche VW fitting connectors that are blade connectors. And then you see gathered together up here are the headlamp, high beam, yellow is low beam, and ground. Those are kind of collected together. This is just the end of that bundle that I showed a few minutes ago with the sleeve that goes back down to the motor. This is the pigtail off of the motor. So there's your red, there's your white with a red tracer, and there's your red with a yellow tracer. I was putting these temporarily using these shrink tube as covers so that when I was doing testing, I wouldn't touch something that was hot independently. There was also in this bundle a yellow with a green, and it is unused. So I tucked the end of it back into the sleeve. We won't be using that. Just another view of that arrangement. So here's one of the motor assemblies out. This is the mechanism that holds the lamp. I installed some LED type high-low beam lamps that I got off of Amazon, and I put a hard connector that I'll then, these are plug-in connectors, and I'll wire those back. But really the story is over here in the lift mechanism. So we'll get to that. There's another view of it, and you see the motor installed. And this would be in the up position. The motor is separated from the frame in this position. This one had another bundle that came down and a multi-pin connector that I eventually abandoned. It was from a previous arrangement that somebody had in there. I trimmed those off and abandoned that, and we'll get to that in a few minutes. You can see some of the pivot points. It's pretty low tech inside there, really. One of the things I had to watch out for was these screws on the side, making sure that the lids that closed down didn't have a bulbous screw out of the side that was going to scratch the paint. And you see this is just a garden variety hard plug. I did get, they're fairly heavy duty. I got them off of Amazon. I just wanted a pigtail so that I could plug and unplug if I wanted to take these LED lamps out later. This is the other bucket. I went in and labeled some of the wiring so that you see the larger cable that brings in, as I said before, the ground, the low beam, the high beam. It also brings in the blinker and the parking light. Those go back, connect to the wire that goes back out, and then that wire goes down to the lamps themselves. I found it very handy to label the wires. Kept me from getting more confused, and you just see some of that up connected there. So I used my ohm meter to look for continuity in various ways. You'll see that in a couple of videos in a few minutes. Again, out of the back of this is the green wire. We'll get to that in a few minutes. The red with the yellow, and then this white. Those three wires are going to be really key as we go on. And this was a ground and ground lug that was back to the motor. So a key is that I put new waterproof relays into each of the one into each of the wells, each of the buckets. And there's some standard numbering with automotive relays. You may already know this, but 30 is the source, is the hot source. 87A is the center pin on this one. 87A is normally closed, so normally connected to 30. This is the ground, that is 86. Excuse me, this is the ground, 85 and 86. Yours may be different, but 85 is the ground, 86 is the coil energizing, so that when 86 goes hot, it powers through the coil down to ground. That changes the position of the relay from the normally closed position with 87 normally open. When it's energized, the connection then goes from 30 to 87 and disconnects 87A. So when operated, 30 to 87 is closed and 30 to 87A is open. Just the basics of automotive relays. I'll play this little video. One of the things I was having trouble with, you'll see, is determining why this motor wouldn't work, and I ended up having to open it up. Probably more information than you want. This is the passenger side motor. It sits essentially like this inside the light frame, and rotates that ball arm. And it rotates in a 180-degree fashion. Stops at the top and stops at the bottom. Oh, excuse me, it rotates and stops at a 180-degree fashion. So one of the things I'm interested in is the red, the green, and one thing to note on these motors is they always turn the same direction. I was thinking that the motor would turn in one direction for up and the other direction for down, and that is not true. It goes in a 180-degree cycle and always turns the same direction. The red with the yellow tracer, those are contacts that go inside to a control wheel. I'm going to open that up now. I believe that the center contact stays in touch all the time because it's a 3-ring circuit there. The outer has no electrical contact for part of the time. The inner has no electrical contact for part of the time. And I just pulled this off from here. It'll only go on one way. So I pulled it off. So the wheel it's a steel wheel that is part of the gear, but it has these blank spots you see here and here. The blank spots are where the contact, these are the copper finger contacts that conduct to the wheel, such that there is one position that the outer contact has no power to it, and there's one position where the inner contact has no power to it. This is really what makes the logic of the system work. We'll get to that in a minute with some relays. And the center one, which is connected to the green on the outside, the center one stays on the wheel all the time. See the path, the silvery path? See the inner path that the finger rubs on, and there's the outer path. So we'll get back to that in a minute. I'm going to look to see if I can tell just by looking. I can't, but I can with an ohm meter. We're going to check to see which is the inner, center, outer of those. Okay, so I go through a process here of trying to determine about the orientation of those. The objective here is to find continuity between these contacts that are on the inside. We know, or by inspection, it would appear that the center one stays in contact with the wheel the whole time. So I was making some assumptions. Some of them were wrong. You'll hear that as I go through and we get to next stages. But I ran into a problem that the fingers were not having continuity with the ends of the wires. And we'll get to why that happens in a minute. The outer one has a segment where it is not in contact, and the inner one has a segment where it is not in contact. And on an angular basis, they look about the same. On a width basis, the real basis, the outer one is wider, but if you look at the angle in angular rotation, I think that they are about the same amount, same number of teeth or same number of rotations of the motor. So we're going to check the continuity of the three, and we'll start with the green wire. Over here, the green wire. A little tricky with the meter and the wires and the camera on one hand. So we'll go with the green. Green is not the inner. Green is the center. It is not the outer. It is the center. Okay, so green is center. Then we'll go for the yellow, the one with the yellow tracer. Red with the yellow tracer. There's red with the yellow tracer that tracks back down into the machine. We'll put our probe in the red with the yellow tracer. There we won't. We'll try. We'll try to put it in the connector. There we go. That is red with yellow tracer. And red with yellow tracer on the wheel is either the inside or the outside. So it is the inside. The inside over here. So a segment, it has no power. So we could do process of elimination for the next one, but we're not going to, because we're just make sure we're thorough about how we approach things. So the third choice is the solid red. And we'll put a connector in to the solid red wire. Kind of got it there for the solid red. And we'll go for the solid red to see if it is the outer. It is. So red, green, red with a yellow. Red outside, green center, red with a yellow inside. While we've got it open, let's check the continuity or resistance between the wheel and the, oh, tricky. We'll go between the wheel and the wheel and the wheel. Where's my black lead? Here it is. So if I touch the wheel with the other one, got that. That's continuity. And if I go to the wheel and this white wire, which I think is that's the other side of the coil. I mean the motor. We're going to show no continuity. Okay, this is a point at which I was a little confused because I was thinking that the wheel was the power source for the motor operation, which it is not. That wheel only deals with the control of telling the motor to go up and down. So it is not actually directly connected. It's simply an interconnect disc for those three wires we're going to talk about in a little bit. To show no continuity, but let's kick up the ohms to 20,000 ohms. Let me run through this because I spent a fair amount of time incorrectly trying to diagnose that issue with the disc and thinking that it might be connected to the wheel. I'll just go ahead and finish this one out. Let's finish that out. Okay. The objective here is to oops. I'm confused. Yeah, I was confused at that point. Okay, so let's go back to the next video, which, let's see if this is the next video. Okay. You can kind of see one of them right there on the first contact. First spot. So the issue on the other motor was that these contacts, the copper fingers there, were not continuous like they were on the other one. They were continuous. So ended up taking apart the housing there that was part of the here that we want to be on this first pin, part of that cover, on the inner pin, and I will give it more of a robust contact. No contact. I'm not getting connection on the, not the center, not the middle. Get connection here and I'm not. Rubbish. I wonder if I need to take that apart and make sure I still have a connection. I've got it to there. For the yellow, we can go back to yellow. So I wasn't getting continuity to these. I did on the other one, but I was not getting continuity on these. Let's run it up and save you a few minutes here.
But that's what I'm going to do.
So I decided to take that apart.
Oh boy, here we go.
Started taking it apart. You can pop this plastic piece out of the housing. Plastic piece pops out, and you're going to start to see these diodes that are in here. The diodes are part of the electrical circuit that prevents a kickback, I'm going to call it, or it's just an element of the design so that the power can only flow one way. So you see these little diodes that are in here. And one of the things we're going to discover when we get to the next one, these diodes are called signal diodes. Let the power run one way. So we got that apart, and everything seemed to make pretty good sense. I was checking continuity in the wrong direction, and of course if you check the continuity in the wrong direction on a diode, you get no continuity. This is just an explanation of how a diode works and the anode and the cathode of a diode. Okay, so let's see what happens in this one.
Hey, I need some help tracking down some information about a diode, about diodes in general. So I've got a contact wheel inside the electric motor, and these contacts that are on the other side of this panel that I've got the probes on have copper contacts that touch the wheel, and at certain times they connect to each other or not to each other or that kind of thing, based on whether or not there is a solid circular pattern. So the inner one has a break just at about 6 o'clock. The outer ring has a break at about 12 o'clock. The center ring...
That's repetitive to what you have heard before.
And I came here. The other motor, I don't think had the diodes in it. I'm going to go check that right now.
I was wrong about that.
And pop that.
So the other motor, when I get to it, you'll see that the diodes were in pretty poor shape. We've already seen this and this and this and this. Forgive me, this is fairly low tech and I'm trying to speed along for you. Okay.
I'm taking apart the motor that is for the passenger's side, and I'm trying to figure out, since I did not have any resistance or open circuits.
You've already seen that.
Well, this gets more and more interesting. So these read direct connect. The reason is that they're soldered directly to the back. But look close. Were those once diodes?
You see they've been burned out. Those are blown off or burned out in between. At some point they must have gotten excessive current, and they acted almost like a fuse. But you'll see that.
They burned out?
So I had to replace those. That's really what the rest of that video is showing. So you need to make sure the diodes are good, and you can only run current one way through a diode, and you cannot run excess current through a diode or it'll blow. Okay, so you see some more of those pictures of the burnt diodes. Now, we're going to get into more about the lift in a second. So this is the main fuse panel. It's tipped out. Notice this particular cable right here, and notice that it has a yellow, a red, and a white. This is a really important piece, and it comes up to a relay that's in the fuse panel there. Come back, and there's your yellow, red, and white that are coming up to the relay panel. When they get to the relay panel, they are connecting into a harness that feeds one of the relays, and they have some other colors here, but these go up and feed a relay that also is going to have those same kind of connections, the 30, 55, 65, 66, 87A, and 87. Typical to relays. That picture's upside down, but you see that they've been tied back into the system. Note that this particular one, this white wire, tags off, goes to the relay. It also goes to another spot. We're going to get to that in a minute. So this is a split, and these are going back into a harness that goes to the back of the relay right here. So one of them goes down to the second fuse from the front. Front of the car is that way. Second fuse from the front. And the second fuse from the front is the license plate light. We're going to get to that in a minute. This is a view of the front of the panel. There again, the connections to that triple wire. So the red, yellow, and white go down past the battery, down into the front of the car, and this is where the magic happened. This goes in T's and goes to the white, red, yellow in each side of the car. So this was coming from the fuse panel, going down under this front end and splitting off, one going left, one going right. And this really solved the problem for me, because when I went to the buckets, there's your red, yellow, white out in the buckets. Trying to remember what this was. Did a little homework in the service manual and discovered that the 1, 2, 3, 4th relay from the front is for the automatic cruise control, of which this car does not have any. So when we look on the back of that fitting, we find the magical yellow, red, and white wires. Yellow, red, and white wires should ring a bell, because look what's up in the front fender. Yellow, red, and white. Look what's in the other fender. Where'd they go? Oh, there they are. Yellow, red, and white. So, what it does, it's very sneaky. It comes off of this relay, feeds down along through this little twisted tear here. Looks like it's kind of homemade. Goes into a T down there, where it tees off, sends one set of red, yellow, white to the front right, the other set of yellow, red, white to the front left, and they magically appear back up in this bucket. I've been struggling with what it is that controls all this. How does it source power? Because all that was in here was the headlight lights, the blinker, the parking lights, and these 3 wires that interconnect between both sides, which I just thought were kind of communication between the 2 motors and the 2 relays. The tricky part is that it is actually sourced back to this relay, and the relay also has a couple of other wires. One of them goes out to the license plate light fuse on the front here, the second fuse, and one of them goes with another wire, this white wire, which is tapped into the red wire. It comes out of the relay, which becomes the white wire out of the yellow, red, white that goes forward. So backwards to this white wire, you come around the other side and the white wire is tapped off of this fourth from the end fuse, which is actually number 18, coming the other way. And that particular fuse, let's see, one was the license plate. Oh, it's the interior lights of all things. And I'm guessing that because the interior lights are hot all the time, well, I've got the battery disconnected, but I think the interior lights are hot all the time. Therefore, see if we can keep from causing a fire. Therefore, the white wire is hot all the time. See, interior lights are on all the time. Key is in the off position. Got power there. And that means that this relay has power coming from the, essentially from the battery, because it's coming hot all the time. And then another leg into that relay is the license plate light, which is only on when the lights are on. So you've got one leg that comes hot when the lights are on, one leg that comes hot all the time, and then a third leg. So those are the wires that are involved in the relay that is feeding the headlight operation. And then of course there's a ground. So gray to the license plate, that's switched. White, which actually goes in as red, but it's the white wire. White is hot all the time. And the ground back here. And then the red with white and the other red with white. Well, they look like they're both red with white coming out of the relay. And they come out to the red and the yellow. If we look and we pull this relay, we should be able to figure out from the relay which is the, which are the cycling. I see the 86, the 87, the 87A, the 30, and the 85. So that's easy. 85 and 86 are the ones that power the coil of the relay. 30 is the feed, and the feed is automatic to 87A, that is naturally closed to 87A. When feed goes across from 85 to 86 and energizes the coil, then the 30 toggles from 87A over to 86 and makes that connection. So there's something of that variety happening here. I'll see if I can decode the pins and the wires and figure out which one is doing what. But I think I finally found the source of power that causes the entire relay system to work, which was absolutely befuddling because I couldn't find a control wire in there. The trick was this T back here, where it's feeding in and feeding left and feeding right. Okay, so with that description, I think it might be a good time to move on. Let me find my video that we just did. Let's see, that was that one. Let's go to this one. By finding the T between these three wires, red, yellow, white, and the headlight motor connections on the left and on the right, each bucket has a red, yellow, white. I was able to get back to identify the 1, 2, 3, 4th relay as the headlight motor relay. This normally would be the spot for a cruise control. I do not have a cruise control, so whoever wired this up set it up so that the slant nose could have a headlight motor relay dedicated. The headlight motor relay has one lead that is always hot. That lead comes off of the fourth fuse from the end. I believe it's actually called fuse 18. And that is the interior light. Interior light is has power to the switch always. So this feeds from this side, fused here, then it goes to the interior lights. So this is always hot. If you come back to the back and look, this is the always hot wire from the interior lights. It's tapped in right here. So this is pin 30 on the relay, and it is the white wire that comes out in each of the buckets here and there. Remembering that this piece goes down and ties together. I've labeled it headlight motors, and T's, it goes right and left. So the white wire that is always hot is pin number 30. The gray wire that is coming over from the side to the back of the relay right here is wired to the license plate light. License plate light, which is, I believe, the third fuse in. Let me see if that's correct. Double check that. Double check that. No, make that the second fuse in, the yellow fuse. License plate lights. So license plate lights come on when the headlights are on, and so that's the power that tells it to. That's the power that tells it that the headlights are on. The pin sequence here is number 30 is the one that's always hot. Number 86 in focus and light. Yeah. 86 powers the relay coil, and that is the license plate lights. 85 on the other side is ground. So when the license plate lights are energized by making this connection, it energizes the relay. And what that does is it takes the power that is on 30 and in a normally closed position on wire that goes to 87A. The wire that goes to 87A is this red wire. So when the fuse is in position, I believe this red wire will be hot all the time. And then when the license plate comes on, the red wire is de-energized, and the yellow wire becomes energized. And that is what is giving signal then to the motor, the motor that has the connections then for the this was all old. This ended up getting cut off. I cut all this off, and it was part of the old system. So that will disappear in some of the future photos. Various combinations of these energized wires to the relays. We'll get to that in a minute. So if I'm correct, if I plug the power back on, put the power on, and I check the voltage with a pin light, check the voltage on the white wire here, the white wire, it illuminates illuminates because those are tied together. Those are tied together. They're not part of the relay. It goes to the relay, feeds the relay, but it's tied directly. So that's hot all the time. The red one, however, I believe is going to need the relay plugged in to make it hot. So let me plug in the relay. And get the pin right on the relay. Plug in the relay. Headlight motors. And that wire came on because that's 87A. It's normally closed. Now if I go turn on the license plate lights by turning on the headlight switch with the key in the on position. The key in the on position. Key has to be in the on position for the license plate lights to come on. So let's see what happens here. Okay, there we go. Now, key is in. I'm going to turn to the first position, and I believe it will not light up yet. Key is on. We're on 87A, so that should be high. But now we're going to go to 87. What you hear is the fuel pumps running. We're going to go to 87 right here. It should not be on. 87. Should not be on until I turn on the license plate lights. And I have the key in position off. 1, 2. Beginning with 2 and run, I should be able to pull this, have the license plate lights come on, which they did, and 87 should be illuminated. And it is. I believe we've broken the code on this. Now if I turn this back, if I turn it back to, it will work on position 1, but it will not work with the headlights off. The headlight motors will not go up and down. Oh, maybe they will. I've got power there. Let's see. How's it doing that? Is it operating the relay? It's hot, so it can operate the relay. Yeah, so it can do that regardless. What it isn't doing isn't, let's see, I could be wrong about this. Nope, as long as those are on. Okay, as long as those are on, you can do it in any position. So I'm going to turn them off. And when I turn them off, what that does is it switches the power back to the red, because now it's in the normally closed position. And by getting back to the red, powers the red wire. So turning on powers the yellow wire. Turning off powers the red wire. Simple as that. Okay, that begins to make sense. I think we've broken the code. Okay. Well, I think I've successfully decoded the upgrade for getting rid of this, which was actually rated at 110 volts and was just an absolute abomination of a setup. And the motor is operating up and down now with this arrangement. The green is on 86, the ground is on 85. This is a waterproof standard automotive relay, but it's waterproof, and it is like $5 Amazon. You can get a pack of 5 of them for $25. They're rated at 12 volts and 40 amps. Red with the white wire, which is always hot. Red with white, which when you go back to the crossover, to the crossover, is actually just white. We cross over with white, red, and yellow over to the other side. But it comes back out and goes to the red and white on the other side too, the other motor. But we don't even end up using the 87A in this arrangement. We have 30 that's always hot. We have the green that can pull in the contact, pull the contact. When it pulls the contact, it makes a connection between 30 and 87. 87 is the white lead into the motor. That's the main motor winding. This green is what energizes the relay and allows the power to flow from the 30 to the 87. 30 to 87 means that we have power up to the motor. Now what you're doing is you're using the ground. Now you have to do the ground. You have to do the contact to activate this. This is activated by either the red or the red with the yellow on the wheels that are on the inside. So this arrangement works. See the connection. So what's in effect happening with the wheel is the red and yellow, depending on where the wheel is in its cycle, will send power to the green. The green activates the relay. Activating the relay connects the always hot red with a white, white with a red, that is actually the white wire back in the main harness. It sends power between, when the relay is activated, it sends power between this and this. That sends power to the motor, the coil of the motor itself, which is really how it runs, how it's set up. There's back in the bucket. This is just some of the test setup. So I'll come back and we'll do another description using the diagrams of how the circuits are arranged. Did a table of what's off and what's on. At different times you can stop the video and call it kind of a truth table. And then this is just a narration of the connections inside the wheel, what is connected to each one and when they're connected. So a key is to understand that there are really two systems inside. There is a control system and there's a power system. And the control system has to do with the relay in the main panel, the relay in the bucket itself, and the wheel. And then the power really has more to do with the headlamps, and they're being switched on and off. That's the relay that's being used to operate the headlamps. And these are just some other pictures of the back of that. Got into that earlier. This one that's on to 18, the interior light, it's just a way to get battery power on a fused connection. I think the important thing is to make sure that you're fused from the battery. So this is a flow of what happens in the circuit at different times, which is using, it's almost like a three-way switch in a house. We have two switches in the same room for the same light, and it toggles. You're toggling back and forth between 87 and 87A, power on either of those, and they are using the wheel to drive the second relay, which in turn drives the motor. So if you think of the wheel as having four different states, state 1, state 2, state 3, and state 4, at the beginning of state 1, the action is to turn on the light switch. That leads you to state 2. State 2, the motor is on and the headlights are rising. State 3, the headlights are up and stopped. Stop position. State 4, the motor is on and the headlights are lowering. You're back to state 1, which is the motor in the stopped and down position. So those are the four keys in this. So stopped in the down, rising, up and stopped, lowering, down and stopped. And this is power in one of the leads, power in the other lead.
Well, I think I've got them where they're supposed to be, doing what they're supposed to do. Let's take a look before we put them back in. So that's motors up, motors down, no key in. Put the key in, go to the ignition position, the first position. Here the fuel pump's running. Motors up, lights on, down, lights on, lights up, lights on, high beam, low beam, high beam, low beam, dip, all good.
So that about wraps it up. I've got a number of other shots of taking apart the armature of the motor, polishing it up, using a little bit of polishing material on the shaft to make sure that the armature is making good contact with the brushes, and the made a big difference in the performance of the motor to get that cleaned up. You'll see I just use a little bit of polish.
Tonight I've been working on cleaning up the armature of a headlight motor for the slant nose, for the pop-up headlights, and I was going to use sandpaper to polish up the copper, but then it occurred to me I have this auto saw that I do my wheels with, and I thought, well, I'll just use that instead and be able to polish the armature, or the where the brushes rub. And so I put some polish on there, and I'll just give it a little spin, and we'll see how it turns out. see what we have. I think that'll do. What do you think? All polished up. Should make good contact with the brushes now, don't you think? Just a thought.
I later did some research, and a couple of people gave me some feedback that you don't want an absolute slick surface there. You want the brushes to be able to make good contact, and there was some discussion back and forth about that, but it certainly improved the performance of the motor. This is just showing that I had to tie back the brushes in order to get the shaft in and out of there, and it allowed me to not have to fumble with those little springs. Here's the mechanism in test. That was without using the headlight switch, and so it let them go up and down pretty fast, or continuously. Here is commutator 2. Got it set up, did a little bit of that polish, notwithstanding what I've learned and read online, but I think it polished up really nice, and the other one went a lot faster. So let's see what this one does. Probably got into more of this motor stuff than you really wanted if you're just watching this for wiring, but this will be a test to see how long it takes to do 10 cycles of up and down. We're going to start with up, and I'll count them. 1, 2. So the test was that one of the motors was faster than the other, and the cleanup ended up speeding up the other motor. This will be a test of the second motor. We're going to go 10 cycles and see how long it takes. 1, 2, 3, 4, 5. So you can see the other one went much faster after it was done. This is a shot of the relays, $25 for 5 of them. You don't need anything really special. I wanted those as waterproof because the buckets do get water in them, and they have a drain, so you do want the waterproof type relay in there. Those were very heavy duty and cheap. That's just one more view of the inside of that ring that toggles the power back and forth between the red and the yellow wires in that main harness. That brings us to a conclusion. I hope that's been helpful. I know it took an hour to do it, and I'll be interested in any of your comments. And my apologies for a low-tech format. I hope the audio is okay, and please leave your comments. Subscribe if you like. I put things up from time to time, but I hope that helps and might be of service. Sure appreciate any of the feedback that you have, and I don't claim to be a professional at this. I'm just trying to be helpful when we can, and hope that all your driving is safe, wheels down, eyes forward, and that you're never testing your seat belts or your airbag, but using them all the time. Thanks.